In your last lesson, you had an introduction into 3D shapes, and today you're going to have a lesson on surface area of prisms. The surface area of a solid is the sum of the areas. Surface area of a solid is the sum of the areas of its outside surfaces. Okay, and we're going to start by looking at rectangular prisms. A rectangular prism, remember, has 6 surfaces, 6 faces. Okay, and we call those the top and the bottom, the front and the back, and the left and right sides. Okay, so you can think about it as like a box, or a die we did in probability. Those are examples of rectangular prisms. 6 surfaces, 6 faces, the top, the bottom, the front, the back, the left, and the right. And to find the surface area of a prism, we're going to add, which is what we said before, the sum of all areas of its faces. Okay, and it's important to remember on a rectangular prism that the opposite faces are congruent to each other. So the top and the bottom are the same, the front and the back are the same, the left and the right are the same. So we're going to find the areas of each of those, and then at the end we're going to add them all together to figure out what the total surface area is going to be. We'll start with the top and the bottom faces, okay? The top and the bottom, we can see the top is right here, and the dimensions of the top are the same as the dimensions of the bottom. And in order to find that area, well, we have to remember that it's a rectangle. So we're going to use the area formula for a rectangle. Area equals base times height. Okay, and we can see the dimensions here are 12 inches by 6 inches. A equals 12 times 6. And when you multiply 12 by 6, you end up with 72 square inches. Remember, area, the units get squared. Now, this is only for one of them. That's only the top. Remember, the top and the bottom are the same, so we're going to have to double that. 2 times 72 is going to equal 144 square inches. So that's the total area of the top and bottom. Now we're going to do the same thing for the front and the back faces. So again, they're rectangular, so we're going to use area equals base times height as our formula. And looking at the front face here, we can see it's 3 inches by 6 inches. Area equals 3 times 6, which is going to end up being 18 square inches. But again, that's just the front face. The back is the same, so we need to double that. 2 times 18 equals 36 square inches. Now we'll find the dimensions of the left and the right side so we can get their areas. So once again, they're rectangular. Area equals base times height. And looking at the dimensions here, well, I know this side right here, this is also 3 inches like we had on the other side. And this segment right here is the same as this 12-inch segment right here. So the dimensions of this side are 3 inches by 12 inches. 3 times 12, or 12 times 3. And that gives us 36 square inches. But again, the left and the right are the same, so we should double that. 2 times 36 is going to equal 72 square inches. Now to get the total surface area, just add everything together. 144 plus 36 plus 72, and that's going to give us a total surface area of this rectangular prism of 252 square inches. So we just saw in the last example that to find the surface area of the rectangular prism, we had to add the top and the bottom faces areas, plus the left and the right faces areas, and then the front and the back face areas. And so if we wanted to come up with a formula that we could use, well, looking at the dimensions here, we have a length, a width, and a height. In order to get the top and the bottom faces, the top and the bottom, it's this length times this width. So we're going to do length times width, and then we have to multiply that by 2 because the top and the bottom are the same. So 2 times length times width, plus the left and the right are the same, so we're going to have 2 again. To get the left and the right faces, that's right here, the width times the height. 2 times width times height will give us the area of the left and the right faces. And now the front and the back faces, the front is this length right here times the height right there, 2 times the length times the height. So this is the formula that you can use to find the surface area of any rectangular prism. Surface area equals 2 times length times width, plus 2 times width times height, plus 2 times length times height. Our next example asks us to find the surface area of the rectangular prism, and we're going to use our formula that we just discussed. Surface area equals 2 times length times width, plus 2 times length times height, plus 2 times width times height. And looking at this prism right here, I can see that I have a length of 15 meters, a width of 2 meters, and a height of 5 meters. And so I'm just going to substitute these values into their place. Surface area equals 2 times the length was 15 times the width was 2, plus 2 times the length was 15 times the height was 5, plus 2 times the width was 2 times the height was 5. And now we'll do our multiplications. 2 times 15 is 30, times 2 is 60, plus 2 times 15 is 30, times 5 is 150, plus 2 times 2 is 4, 4 times 5 is 20. And now I'll just add these numbers together, 60 plus 150 plus 20. That's going to give us a total surface area of 230, and the units are meters squared. In the next example, we're going to find the surface area of the triangular prism. And remember that the triangular prism has 5 faces. It has 2 triangular bases. There are 2 of these. And then there are 3 different rectangular sides whose areas we'll need to find. So let's start with the triangular bases. Okay, remember for the area of a triangle, area equals 1/2 base times height. And remember that the base and the height have to be perpendicular to each other. They have to form the right angle. So looking at my picture here, I can see I'm going to need this length right here and this length right here because they form that right angle. Okay, and so I know this segment is the same as this segment down here, so this is 15 feet. And then this segment right here is the same as this 8-foot segment down here. So I'm going to do A equals 1/2 of 15 times 8. Okay, and when I multiply those together, well, that gives me an area of 60 square feet. Okay, but there are 2 of these triangular bases, so I have to take this number and I need to double it. 2 times 60 is going to equal 120 square feet. So this is the surface area so far of the 2 triangular bases. Now I need to find the surface area, or the areas rather, of the 3 rectangular sides. So for each one of these, my formula is going to be area equals base times height. And it doesn't matter which of the rectangles you call A, which is B, and which is C. So we'll start with this rectangular face right here. And tracing it, I can see its dimensions are 15 by this height right here, which is this 20. Area equals 15 times 20. And when I multiply those together, that gives me 300 square feet. Okay. Next, let's find the rectangle over here on the side. I need this length by this length, and so I can see again the dimensions are 8 feet by 20 feet. Area equals 8 times 20, which is going to be 160 square feet. Okay, and now the only other rectangular face that I haven't done is the one that's kind of in the back there. It's going to be this dotted line segment. And this height right here, well, this dotted line is the same as this 17, so this is 17 feet by the height of 20 feet. Area equals 17 times 20, and when I multiply those together, I get 340 square feet. Okay, so now that I have the dimensions or the areas of all of the faces, I'm just going to add those all together. So I'm going to take the 120 and add 300, plus 160 plus 340, and that's going to give me a total surface area of 920 square feet. Okay, just like I did before with the rectangular prism, I want to see if I can come up with a formula that I can use to find the surface area of a triangular prism. And it's important to remember that on a triangular prism there were 3 rectangular faces, and I'm going to call them A, B, and C. Let's change those 2 to B and C. plus the two triangular faces. So I need to find the area of all of those. So in order to find the areas, well, let's call rectangle A the bottom here. The bottom, if you look at the dimensions, is the length times the width. So I need to do length times width plus rectangle B. Let's call rectangle B this one over here on the side. It's going to be the length times this variable S right here, whatever value that happens to be. Length times slant S plus, let's make the final rectangular face, the one that's over here on this side. It's going to be this times this dotted line right here. This dotted line is the same as this segment right here labeled P. So P times the length, length times slant P, plus the two triangles. The triangles, remember, it's going to be 2 times 1/2 times the width and the height are perpendicular here. The width times the height make this right angle. 2 times 1/2 times the width times the height. But remember, if you do 2 times 1/2, you just end up with 1. So this is just the same as the width times the height, plus the width times the height. So this is the surface area formula for a triangular prism. Surface area equals length times width plus length times slant S plus length times slant P plus the width times the height. In the next example, we're going to find the surface area of this triangular prism, and we're going to use our formula here. Let's label what each of these segments are. Remember that the width and the height have to be perpendicular to each other. So we can see the right angle back here. This 10 is going to be the height, and this segment here, which is the same as the 50 right here, is going to end up being the width. This segment right here is the length because it connects the two triangles together, and that's going to be 60. Okay, these other two numbers represent the slanted sides. One of them is 20, one of them is 30, and it doesn't matter which one you call P and which one you call S. Let's call 20 slant P and 30 slant S. And now we can just substitute into our equation. Surface area equals the width of 50 times the height of 10 plus the length 60 times the width 50 plus the length again was 60 times slant P we called 20 plus the length 60 times the slant S we called 30. And so now we'll do our multiplications first. 50 times 10 is 500 plus 60 times 50 is 3,000 plus 60 times 20 is 1,200 plus 60 times 30 is 1,800. And now all I have to do is add those all together. And when I do that, I end up with 6,500 square feet. We can see right here that the units were feet, and for area it has to be square feet. In example 3, we're going to be making the stadium cushion. It's in the shape of a rectangular prism. And it says that the foam for the cushion costs $1.50. The fabric costs 50 cents per square foot. How much does it cost to make this cushion? So we're going to have the fabric that goes around it, and then we're going to put the foam on the inside. So we have to first start by finding the surface area. S equals 2LW plus 2LH plus 2WH. So the first thing you should do is find the surface area. So we found that the surface area is 7.5 square feet, and now we want to know the cost to make the cushion. We're told that the fabric is 50 cents per square foot, so we need to do 50 cents times our square feet, which was 7.5, plus we need to add in the cost of the foam, and the foam was $1.50. And so if we multiply 50 cents by 7.5, we get 3 75 hundredths, plus the $1.50, which gives us $5.25. In our last example, we're looking for the surface area of the triangular prism, and I've got our formula written out: width height plus length width plus length times slant P plus length times slant S. And for the width and the height, remember they're perpendicular to each other. That's going to be 8 by 15. Plus the length here is 25 times the width of 8. Oops, the length was 25 times the width of 8. Plus the length was 25, slant P we can call 15, plus the length was 25, and slant S we can call 17. So go ahead and finish calculating the surface area of that triangular prism.